Hi, everybody. Welcome in. We're just going to wait for a few more folks to join us and then we'll get started, all right? All right. So a few folks are still trickling in, but why don't we get started? I just want to say hello. I'm Gabby. I will be kind of running the show here. I just want to share a few housekeeping items before we start. The first is we are recording. So we will be sending out the recording later today with the video. So if you have to hop off early, no worries. We'll send it over to you. And you can always reach back out to us if you have any questions after. As well, we will be using the Q&A function. So at the bottom of the screen, you should see Q&A and you can pop any questions you have there and we'll be able to answer them at the end. We'll have some time to go over any questions. But yeah, with that, why don't we get started here? Okay, so I'm here. There's an echo. Okay, hopefully it goes away. Alex or Mickey, do you hear an echo on your side? Okay,
No, not on my
cool.
end.
Okay, cool. Well, we'll keep going and then go from there, all right? Okay, so first I'd like to introduce our wonderful speakers. We have Alex. Alex is the CEO of WarpWare, where he has guided the platform's use across missions, ranging from launch vehicle flight software to cislunar guidance, navigation, and control. Before starting WarpWare, he was the project and technical lead for the flight dynamic software team behind Sierra Space's Dream Chaser space plane, leading a large group of engineers building the high fidelity simulation of every phase of flight, rendezvous through entry, descent, and landing. Next, we have Mickey. Mickey is the COO of WarpWare, where he leads commercialization of the company's unified software platform for spacecraft design, testing, and operations. Before WarpWare, he served as deputy chief engineer for the Orbital Reef program and played an integral role in Sierra Space's $1.4 billion Series A. He brings deep experience in payload integration and sales across both commercial and civil space. So with that, I will let them take it away.
Yeah. Hey, everyone. So very excited to talk to you about how to get payloads, how to get spacecraft to space fast. One of the great privileges we have doing what we do as a business is we get insight into a lot of, companies ranging from space startups to, established space players, and we get to see the common themes that lead to success and help companies get to space fast and the sort of the pitfalls to encounter. So that's what we're going to be talking about today. Excited to talk and then, engage with any questions you have as well. So quick background on who we are as WarpWare. Our whole mission is to help companies get to their flight fast. So what that means is we consider ourselves a mission partner. So where a lot of times you'll work with someone and they'll do some part of your mission, we really like to dive in at the very start of a mission and help you execute as quickly as you can from start to finish. We take a lot of pride in working with extreme speed and capital efficiency. We work with larger companies, but we also like to work with smaller companies and startups. And no startup wants to bring in someone to help them with something that's less fast or, cares less than they do. So that's something we take a lot of pride in. And we really like to treat the missions that we work on like our own. And a lot of the insights that we're going to be able to give in this presentation come from the fact that we dive in and we treat the problems on these missions, as if they were, our very own missions. So excited to talk in more detail about that.
Thanks, Alex. So, the reason why we exist and why the WarpWare platform exists is that in our experience with developing payloads and spacecraft, we realized that there's this really large software challenge that comes with developing a piece of hardware and sending it to space. And that comes from a lack of off the shelf tools and the fact that they don't integrate, and then the fact that when you're building something, you want to take it from concept to operations without having to jump across a bunch of different streams. So that leaves you with two options. You can either subcontract out all your software development, which is an expensive maneuver, or you can build a team in-house that's focused on your software. But this is a very large, time-consuming process. So, and this is a process that is replicated across the industry. So within organizations and companies, every single person is rebuilding this core capability from scratch. And you kind of have to like spend 2 years running before you can get out the gate. And it's like reinventing Microsoft Word before you have to write a document. So we built the WarpWare platform to fix that. And the WarpWare platform has been already deployed on a variety of vehicles and platforms. The Leap team used it for their Bullfrog launch vehicle. We were able to get them ready to launch in less than 6 months. So everything from getting them with their FAA certifications to their onboard control, as well as all the interfaces that their operators use to interact with the vehicle on launch day. On the Dream Chaser program, our team helped with a lot of their flight operations tools, as well as performing entry, descent, and landing analysis for them. And with Orbit 5, the gas stations and space company, we're an end-to-end partner for them. So the WarpWare platform is used for flight software, guidance, navigation control, simulation, as well as mission operations. And these are just to name a few. So the way that I'll keep going. The WarpWare platform, the way that it works is it's built on an end-to-end architecture that flows with you from design through operation. So when you're at the mission concept stage, you use the Warp Twin capability to do your mission analysis, perform high fidelity simulations, and do a lot of things like communications budget analysis and power budget analysis to size your vehicle and decide on the trade studies that are important for you. And once you get your vehicle optimized, the WarpOS flight software enables you to build at 80% complete because we support a lot of hardware drivers for the vehicles that you're probably thinking of building on top of. So you don't have to worry about the hardware abstraction layer, the command and telemetry, storage, GN&C, etc. And you can focus on the differentiated 20% that your mission is built on top of. And our development kit enables a lot of really great capabilities with that to make this as easy as possible. We think that you could be deploying on hardware within a week using our platform. And so you're using this for software development, and then you use the Warp Link capability to do verification and validation of your software on your hardware, doing hardware in the loop, combined software and hardware in the loop, as well as real mission operations once you launch your vehicle into space.
So what does that look like in the context of an actual space mission? So if you look at the sort of purple box on the screen here, that's what the WarpWare platform actually covers. So that includes WarpOS, which brings the bootloader, the firmware that actually makes sure that your software can operate reliably on hardware. Your built-in schedulers, your application layer. We have essentially it's sort of an app store analogy where to build a mission, now you're writing an app in the app store as opposed to building everything from the ground up. It comes with a tremendous amount of guidance, navigation, and control built in for everything from launch vehicles through spacecraft, a test platform, and then the ability to actually do trajectory analysis for the FAA if you're a launch vehicle or other governing bodies if you're not. So WarpOS, but then there's also the Warp Twin component that comes with the ability to do mission analysis, simulation, determine vehicle performance, determine how your mission is actually going to look, what you can do when you're actually on orbit, V&V of the actual flight software, and then the system model development. So what we do is essentially we take those two components, which are already built out to be sort of the 80% software layer that you need to execute your mission. We take in, vehicle mission data, which includes, what are the vehicle properties, what are the sensor capabilities, where are we launching from, where are we going, and feed that into the simulation. Simultaneously, we take, hardware data. What are we actually having to do in the software? What are the system requirements? What are the specs and interfaces? What is your flight computer? What components are you using? Tie that all in. And basically what we produce out of that is operating software that can either deploy to a fully virtual environment in the Warp Twin world where you're actually using your flight software in this virtualized environment, or can deploy to a test platform or to the actual vehicle and operate the vehicle. And then when the vehicle is flying, we have our ground-based Warp Link platform, which basically allows you to do commanding, receive telemetry, process data on the back end, visualize the state of the vehicle, derive intelligence from what you're seeing on orbit, And it also comes with pretty extensive capabilities that are really nice in terms of actually achieving a missions or a successful mission. One of them is like an operator's manual to make sure that you can actually operate the vehicle, and then of course a training platform to be able to prove that your vehicle works before you fly it. So let's dive into what the individual components of the WarpWare platform actually are. So the first component is what we call WarpOS, which is our flight software platform. Essentially, it is a space software platform that comes with everything you need to operate a vehicle in space. So from command and telemetry through deterministic operations, through an application layer, through guidance, navigation, and control. But it's designed to be extremely lightweight and easy to use. We've run it on everything from a very small microcontroller up to a flight processor. And so what that means is it can work across a variety of missions. It can deploy on top of any operating system or go bare metal. It's very flexible operating system to use for everything from very, very small items to very large vehicles. It comes with built-in GN&C and firmware. So if you're working with the WarpWare platform, you don't have to start from scratch to build out everything you need to operate a vehicle reliably, from navigation, determining where you are on orbit, through actually controlling to an orbit or to a mission profile, as well as built-in firmware to deploy to different hardware and deploy to be able to operate with different sensors. We come with as much built-in as possible, so that way you can focus on your mission and working extremely fast on an extremely tight cycle time, as opposed to building everything from the ground up. The really exciting thing, it can deploy to payloads, components, and then the actual core flight computer. So what that means is that most vehicles, actually, you think of it as it's one computer, but something that we've seen with pretty much every mission we work with is it's very rarely one computer. Our next mission we're flying is 7 computers, and very often you end up with the sort of ancillary computers having to write software from scratch to be able to talk to your main system. But Warp OS is designed to distribute to all these different systems, and they can all speak as if they were on the same processor, which is a huge advantage if you're trying to integrate payloads or even just trying to operate a more complex vehicle. And then the final benefit is it scales to all domains. So it can work in everything from something that's operating just on the ground through actually operating in space through cislunar space. It's done all of those things. The other component of the WarpWare platform is the Warp Twin simulation. So what that is it's a simulation platform that's physics-based. So it's a full, true 6 degree of freedom simulation. You can do Monte Carlo and high fidelity guidance, navigation, and control type analysis. But it also scales to be able to put software in the loop, so running actual flight software in the loop, real time or faster than real time, as well as hardware in the loop or any blend of those. So if you wanted to blend some elements of hardware in the loop to test flight software with elements of software in the loop to be able to simulate an orbit at the same time, that's something you can do. But because it's so easy to use, and because it can be used for mission planning very easily, but then also scales to Monte Carlo, software in the loop, hardware in the loop, what we actually end up doing is we create a digital thread of a mission that works from the very start of a mission all the way through when you're actually flying and operating the vehicle. And that saves having to recreate work to rebuild a simulation to test the flight software. But more importantly, it eliminates these sort of technical cliffs that you get in a mission where you move from one simulation platform to another, or one analysis framework to another, where now you lose capability to analyze things, or now you introduce the possibility that 2 things don't match. By creating this single digital thread, we've drastically improved the reliability of missions. That's enabled partially by the sim framework, but it's also enabled by built-in models that we have in the sim framework. So everything from sensor models, IMU, star tracker, through actuator models, from high thrust impulsive transfer to low thrust transfer, to high fidelity environment models. It's got everything out of the box that you need to be able to analyze a mission. The other thing that we can do with the Warp Twin platform that we sort of leverage it for very often is to integrate it as the back end to mission operations. Mission operations is, in our experience, one of the most overlooked part of a mission. We always like to say that the operators are the first customer of a vehicle, because you might be flying something for the Space Force, but the operators are the ones who have to actually, go fly the vehicle. And so what we do is we have a telemetry framework that can pull in live data from spacecraft. You can send commands. You can actually interact with the spacecraft. And that's a huge component of what you need to actually fly a spacecraft, right? You need that ground component, because if you're not talking to your spacecraft, you don't have a spacecraft, you have a space brick. However, through the integration between the simulation, the flight software, and the operations platform, we have some unique capabilities that you get out of the box that don't necessarily come with anything else that you can do. One of them is sim-driven operator training, right? To be able to actually manage the faults that inevitably rise when you get a vehicle on orbit. you need to be able to actually operate your vehicle, right? The folks operating at Catalyst, the Swift rescue mission, are trying to debug reaction wheels right now. The only hope they have of doing that is because they trained on the ground for this exact situation, right? Using Warp Twin as a backend and using flight software and Warp Link in the loop, you can do repeated operator training out of the box easily and train as if your mission were flying on orbit. But we also produce, operator manuals, command and telemetry databases out of the flight software immediately. So there's no mismatch between I'm trying to operate my spacecraft, but the version of the ground software doesn't match the version of the flight software. All these little things stack up to help lead to a successful mission. And that's the sort of thing that we're very focused on with the WarpWare platform. Yeah, I think we're 2 ahead.
Sorry, one second. Yeah. There we go.
Okay. So the last thing that the WarpWare platform really lets you do is it's focused on this, test like you fly like you test type philosophy. We have our built-in app and development test harness. What you can do is you can deploy those apps to a test environment. You can deploy them to a hardware environment. You can deploy them to a simulation environment, and then you can deploy them to your real vehicle. And it's entirely transparent. It's all built in. What that allows you to do is have this great hardware testing thread, the same operations platform we talked about a slide ago that lets you operate your vehicle. You can also use to test your hardware, view data live. It makes it extremely easy to go test and iterate very rapidly with your actual software. Producing automated test reports, again, little things that go a long way in terms of being able to actually execute a mission and execute it with success. The ability to produce full test reports for hardware or simulation or whatever it is you need to actually verify your mission before you fly it is all really huge to leading to actual mission success. Again, all this is about testing like you fly, right? The way that you reduce on-orbit errors and challenges is by making your ground environment as realistic as you possibly can and testing as much as you possibly can. So that way, when you get in flight, there are no surprises. And that's what the WarpWare platform is designed to enable. So at the core of all of this are some real software truths that we've sort of come to realize at WarpWare that lead to huge mission success, but if ignored, can kind of lead to a mission failure. The first one is that 80% of the aerospace software stack you need to fly a vehicle is actually extremely expensive to build and not proprietary, right? Command and telemetry frameworks have been around forever. They're not a differentiated capability. Physics, they haven't changed for a while. Physics is kind of the same all the time. So simulations don't need to be changing all the time. There's a tremendous amount of software that you need just to be able to make a vehicle that isn't a differentiator, but there is sort of a 20% of the software layer that is extremely valuable, that defines your mission, that is, the key capability that's going to take you from, basically allow you to build a whole business or build a whole mission on top of these capabilities. And so what we try to do at WarpWare is take that 80% off the table so that way your team can focus on the 20% that is extremely differentiated and extremely important to your mission. Integration matters. And this is maybe the biggest point out of the whole presentation is the great space companies, SpaceX is an example, but you can think of, quite a few others that are, really achieving a lot of mission success. What they focus on is cycle time. It's not necessarily about how efficiently you can move from A to B. It's when something goes wrong, how quickly can you turn something around? For instance, with the LEAP Bullfrog mission that we flew, we had a drastic change come in 2 days before flight. And because of WarpWare, we were able to turn around a quick change and be able to actually fly the vehicle 2 days later on the basis of that change. The cycle time where you have to go from this is broken to we have a solution and it's fixed and tested is extremely important to being able to move fast and achieve success in the space environment. And what we mean by that is as you move from design to the actual implementation of your vehicle, right? So design in sort of a mission planning framework to implementing your software, to testing your software, to actually operating your vehicle. How tight can that loop be? And a lot of how tight that loop is depends on integration. If I make a change in the simulation, how hard is it for me to mirror that change in the flight software, to test that change, to turn that into an operations manual and command and telemetry that my operators can use? And WarpWare is designed to make that go extremely fast, drive down cycle time with the focus on helping to achieve mission success. And then the other kind of hard truth for aerospace software is typically it ends up costing 10 times what you first estimate. That's not our quote, that's a quote from an astronaut friend of the company. And very often software ends up being 30% of your mission cost, regardless of how fast and efficient your team is, right? If your team's really good, is still 30% of the mission cost. And with WarpWare, our goal is to drive that down below 10%, put the focus on the mission, not on building capabilities that everyone has just to be able to try to execute a mission.
Yeah, so the WarpWare platform, it enables companies to operate much more efficiently. So when it comes to getting your payload to orbit, we enable you to go to orbit 6 times faster. So instead of taking 18 months to develop and test all your software to a robust level, you can get it to under 3 months. It lowers your software costs. So, I mean, if you're paying for licenses to a bunch of different platforms and hiring a software team in-house, you're looking at spending over $2 million to build the software layer that WarpWare provides you with. And we provide it to you for less than $200,000. It saves you over 8,000 hours worth of mission per mission versus building in house, and over 5 engineers worth of value in terms of what it would take to replicate this capability and to continue to update and make it work for your mission. So it reduces your development time, it lowers your technical risk, and it future proofs you. So that what you're flying today on a small sat, you could fly on a lunar lander in the future and a space station beyond that. So that the WarpWare platform enables all those kinds of efficiencies. And I mean, we exist to help you get to flight fast. So if you're interested, reach out to us. We can do a little 30-minute discovery, talk through your mission, give you a live demo of the platform end to end, and scope it to how your mission would look. And then we get you warping. So give you a license that's your mission need, and then we can go from there. Really appreciate you guys joining us. I think we can turn it over to some Q&A.
Amazing. Thank you so much. All right. I'm just going to stop sharing. So if you have any questions, feel free to pop them in the Q&A section and we will answer them, I believe. Yeah, one question is, what's a good email to use to contact WarpWare?
You can just reach out directly to me, alex@warpware.co.
Okay, I'll put that in there too. Amazing. And then we have another question. We already have a full software stack that we use. Is there any part of your product that helps us?
Yeah, absolutely. The analogy that we use really often with space missions and getting to space is if you are going on a vacation and you wait until the last second to pack your suitcase, you're going to start throwing a bunch of stuff in there, trying to get get going on your mission or your vacation. And you get on your vacation, you're like, man, I forgot some things because I built this out just for for this mission, right? So WarpWare is designed to scale, is designed to plug in and help fill gaps, right? So the operations capability that we've got in terms of the ability to integrate SIM with your actual live command and telemetry, or frankly just the ability to use our simulation platform to test your existing flight software stack, either because it can fill a gap and it helps you to test like you fly a lot more than you could, or even as a double check on existing testing that you've already done, are really easy places to get started, right? Just using the simulation platform is something that we've designed specifically to be really affordable, so that way you can go double check, make sure your mission's going to work with your existing software stack, and you don't have to worry about using the whole platform just to be able to try something out. So there are a lot of different gaps we can plug because WarpWare is designed to scale, right? It's that you packed days in advance, and you get the advantages of that.
Awesome. Another question we have is, what kind of third-party solutions can contribute to this platform? Is the platform easy to interface with via APIs?
Yeah, so the WarpWare and specifically the Warp Twin platform, because that's where you typically are doing your ground stuff, and most of our ground side is routed through the Warp Twin platform, is designed specifically to be friendly to talking to other things. Part of that is because we need to make it really friendly to talk to different flight software. We've worked with all flight software, ranging from CFS to custom in-house built stuff from the ground up. And so in order to be able to do that, we also have to be able to talk to anything. At the sort of the scripting layer, it's in Python. We also have an actual built out API. So it's designed to be able to talk to various other different platforms, different capabilities. There are a few different companies we're talking to where they've got really exciting capabilities that maybe they're specialized in different areas of simulation, where they're experts that have sort of these frontier models that no one can match. we're really excited to integrate those into our platform and offer this really great capability stacked on top of what you get out of WarpTwin.
Awesome. Does the data we use for our missions stay confidential to our company, or is it in some models that others will use?
Short answer is your data stays completely confidential. So typically we deploy the whole WarpWare platform onto your local system, and then you run it and you can treat it as if you own it. You can treat the code basically as if you wrote it, right? It's really giving you a kickstart in terms of everything that you're doing. Something that we do try to do for partners who are open to it, and this is completely an opt-in thing, is basically sort of crowdsource certain models and certain elements of development in a way that benefits everyone. So if you can think, and this is a very real thing that's happening, we're flying, 5 spacecraft missions, and the spacecraft needs a really good ADCS model. We wouldn't take your ADCS data and feed it back to everyone. That would be, not good for you or for anyone else, right? That data stays local on your system. But we can help build out a generic ADCS model that we can share among all of our partners. That way, everyone is benefiting from the development that we're doing without losing, control of their proprietary data and their proprietary capabilities.
Great. And is it difficult to do customizations on top of WarpWare for the special functions that are unique to our missions?
I'm so glad someone asked. The whole point of WarpWare, if you look at Mickey and I's background, we worked on really custom vehicles at Sierra Space, right? We were building mostly custom capability from the ground up. And so we really respect that, to execute a mission, if your mission had no elements of it that were custom, you wouldn't need to fly it. It would have no, unique differentiation, right? So WarpWare is designed to be extended. It is designed to be customized. And we have our application layer where basically you can build custom applications very, very easily. And also a model layer where you can build models that are custom to your spacecraft or your mission very, very easily. And the whole point for that is to allow you to go execute a mission. So that's probably one of our best differentiators, is just how easy it is to customize WarpWare to your needs.
Wonderful. I think this might be the last question before we wrap up, but if there's any more, feel free to pop them in. It's how does working with WarpWare compare to building in-house using open source?
Yeah, that's a good question. So, open source, there's some open source platforms like, CFS that does a little bit of flight software. There's really a few differentiators. If you look at, again, cycle time is what leads to success in complex space missions. My biggest challenge I had when I was working at Sierra Space wasn't the ability to hire people who are talented. It wasn't, whether to get something that technically worked. It was when I hired someone, it took 6 months for us to be able to train them on our software platform just to be able to start adding value, right? Training is huge. What happens when you have a question and you can't solve something and it takes, 3 days to figure out how this platform is working? What happens when you really just need a little bit of support, or, your team needs to surge and you don't have that backing to be able to do it? Those are all huge things that, WarpWare, through being designed to be easy to use and through the partnership that you get when you work with us, is really designed to speed up that time. But more importantly, WarpWare comes with a lot of things out of the box that you can't get open source, because it's typically behind an EAR or an ITAR wall. For instance, all of the guidance, navigation, and control, not just algorithms built up, like we have Kalman filters for spacecraft, but the core capabilities to do those sorts of analyses and things are things that are pretty hard to track down open source. And if you can find any open source, it's not really very usable and certainly not designed for space missions. Things like CFDP to transfer files from spacecraft to ground doesn't really come built into platforms that you're going to go get open source, right? But transferring files to ground is a huge capability. And so we've really structured the license to be something that is going to add way more value than the cost, because the whole point of working with WarpWare is that it's the fastest way for you to get to space, and also the most affordable.
Wonderful. Okay, I think that's all of our questions. Yeah, I just want to thank you both so much for your time and for sharing this space with us. And like I said, we'll be sending the recording out after this. And we look forward to hearing from you with any questions as well. So thank you all so much for joining us. Take care.
Thanks, everyone.
Thanks, everyone. Bye.
Bye.